Hi, this is Nikos Petrelis, and in this video we are going to examine another operation of the timer counters. In the last video we examined the output compare operation. Here we will test the PWM, the pulse width modulation. Let me tell you a few words about what pulse modulation is. If we schematically represent how a timer changes, for example, if we have a timer that goes from 0 to 100 and then overflows and starts again, we will see that the measurement would change gradually from 0 to 100, 0 again, from 0 to 100, etc. Setting a PWM operation means that a specific output pin will be toggled actually whenever the value of the timer passes from a specific threshold. For example, if we set the threshold for PWM to 50, then you can see that whenever the counter reaches the value 50, it will toggle again. I think the correct is that whenever overflows, it returns to the previous state, but I'm not sure. Maybe the clearing of the PWM signal to 0 happens at the next time it reaches the value 50. So let's create a project directly to see what will happen and how we will configure a PWM operation. We start a new project and we will use a single LED, let's say the one that is assigned to pin PD12. I have to select initially the microcontroller, the specific microcontroller. So let me find it. It's STM F407. Here it is, and I think this is the one. It's VGT6. Okay, so we selected the correct microcontroller. We start the project. Okay, and we simply select the PD4 and assign it to TIM4 channel 1, again as we did in our previous video. Next, we go to the timers. The timer 4 is the one that we're going to use. And first of all, we select the clock source, the internal clock. Remember that this clock has a frequency of 16 megahertz. And on the channel 1, we select PWM on channel 1. This is the option that will be used, PWM on channel 1. Concerning the parameter settings, we will use the ones we used in a previous video. So the prescaler is set to 16,000. The counter mode is up, but the overflow value of the counter is reduced to 1000 so that it overflows every 1 second. And then moving below, we go to the PWM generation channel, and this tells us which value we will use to switch the specific pin, to toggle actually the specific pin. So by setting at 500, we mean that when the counter reaches the value 500, this happens at every half second, then the LED will toggle. Okay, I think let me see if there's anything else that have to be set to avoid any error. Only the value is changed to 500. Okay, nothing else needs to be done. So I move. This is the clock configuration, the project manager. It is within the directory I like to be placed. So I call it PWM_test. generate code. No. Before doing this, we should not forget MDK ARM selecting here so that the project will be created in the correct format that can be read by the Kale Microvision 5. So we wait for the source code to be generated in the directory we selected. It will not take long. Okay, open folder. It will not open from here, but I can find it elsewhere. Let's see. It is working directory. New lab. And this is PWM test. Within MDK ARM, I find the project file. I start, Kale Microvision 5 starts. Good. I should not forget that in the main program, I should initialize the PWM operation. This can be done by copying this value here, this command here. Copy, paste. Okay. And I will probably have to set, as I did in my previous projects, the device startup option, because some initialization files are not included from the okay. So let's build the project, build target. Maybe I have to change something later because maybe another file will appear under this folder CMSIS with the same name as this one, as I did in my previous video, but maybe this does not happen if I select immediately the startup, if I tick the startup option immediately before building the first time the project. So wait for the output messages to see if we have any error now. Okay, we have some errors, so let's see what happened. Okay, the problem is that I do not declare, I should not declare this here, this command here. This is a command, not a declaration, so I removed it. I should move it underneath the initialization. Here it's its position. So that was the error. I build the target again. No error, so I can move forward and connect my board. You can see it here. I connect it to my USB port. Okay, and then I have to set my debugger to ST-Link, change the JTAG port to software. It is recognized, the board is recognized. Okay, so let's download this code to my board. Everything has been turned off during programming. The Flash program has been stored, and now I will start a debug session. And let's start running. You will see that the LED blinks, and at appropriately and approximately, at about 50% of the duty cycle is on and 50% is off. Let's see how can we change this one. I move within my code, stop debugging for a while, and see the point where I have, during the initialization, where I have set that the PWM will toggle anytime the pulse crosses 500. So if I change this one to 200, let's see what will happen if the duty cycle will be that for 1/5 of the second the LED is on, and for 4/5 of 1 second is off. I build again the project. Download to the flash. And let's start a debug session. Okay, and let's start running. You will see that now the duty cycle has been significantly reduced. For a short time it is turned off, and most of the time it is turned on. This actually verifies the fact that, as I said at the beginning, in the PWM, the PWM signal is toggled at the end of counting, not when it crosses again the same value. Because if it changed anytime it crosses the same value, then we actually would always have a 50% duty cycle. So this is not rational.